like the primordial ones, and how there might be like gamma rays coming from them, and um, if we have any hope of finding one that's sort of in our own solar system, let's say, what are the chances and things like that. So that's sort of the point at which we uh, left off, and we can continue from that point here. No Doro or Reese. No, I think I missed them. It's probably too late / early for Reese, and then it's probably too late for Doro. I might have missed them. So, of course, if a black hole as close as Pluto, so let's say if there was a black hole at the same distance as Pluto, this is the case that we're looking at right now. From the book Brief History of Time by Stephen Hawking, from the chapter Black Holes Ain't So Black. What is a chemistry? So if a black hole as close as Pluto were to reach the end of its life and blow up, it would be easy to detect the final burst of emission. But if the black hole has been emitting for the last 10 or 20,000 million years, so a million has 6 zeros, 1,000 will be 3 more, so that's really a billion. So if it was for the last 10 or 20,000 million years, or really a billion years, the chance of it reaching the end of its life within the next few years, rather than several million years in the past or future, is really rather small. So part of the conversation or the thinking here is maybe we just are not catching the thing at the time when it would be bursting up into flames or reaching the end of its life or something like that. So part of it is also the timing, and we as human beings on Earth may or may not overlap in time with certain sort of astronomical or cosmological events. We are only here for, pretty recently compared to the age of the universe, even the age of the Earth, right? 4 billion years, 13.6 billion years. Those are much longer than while we have been around. So to expect something kind of rare to happen overlapping with our lifetimes and our civilization on Earth is a little bit maybe far-fetched. So that's sort of what's going on here. And the thing is, with cosmology, astronomy, astrophysics, like sometimes it's really the giga-year that matters, not so much the century or the millennium or even thousands of years, but more, or even a million years is kind of short compared to hundreds or thousands of million years. So for example, the sun, we consider the sun to be pretty permanent. We get all our life, energy, power, obviously all that heat, everything we need to really be alive from the sun. The sun promotes photosynthesis. Plants are alive. Plants are very helpful for a number of reasons, things like that. But the sun is actually quite young compared to, say, the galaxy or the universe. The sun has only gone around our galactic center 20 times, just around 20 times. So in the galactic age, the sun is like a 20-year-old. So the sun is a very young star. By the time the sun becomes a giant and is closer to its life cycle, end of its life cycle, we will have merged with our neighboring galaxy, Andromeda. And our galaxy's shape will be different. We will be part of a bigger elliptical shaped galaxy by then. Who knows where we will be as human beings, but those are the sorts of timelines to keep in mind when you're considering things in cosmology, which is the study of the universe, and astronomy, which is the study of the heavenly bodies. Okay, so